Naren from Virginia. So my talk basically is usability challenge, particularly when you're using Bicluster to support Sensemaking. And to categorize this work, basically like interfacing machine learning. So how you can show the machine learning stuff to user and allow user to make sense of that. So let's start this way. Suppose you are an intelligence analyst, as a server does. Your basically daily work is reading documents, and your task is to identify potential terrorists. What would you do? So you might read the document one after another, right? And try to figure out the names in the documents, and possibly taking notes of that, and then read and find another whole bunch of people, and might try to find some weird activities, like why these three people always visit some places together, right? And why they travel particularly on the same days, and why they make phone call so often with each other, right? So such kind of a pattern reveals some weird activities. Why those people doing these things together? Think about that. Potentially, they try to plan to do something, right? So this particular kind of a relationship, we call it coordinated relationship. So definitely you can see more relationship from the text, but we particularly focus on this part. So why we focus on this coordinated relationship? So as I just mentioned, in intelligence analysis, it represents a coordinated activity. But in different kinds of domains, like bioinformatics, they represent kinds of how do you find similar genes, particularly under a set of conditions. And also in the cyber domain, you possibly find the collaboration among different apps, particularly in some parts of these apps collaborate with each other to steal the information from the user. And also in the business intelligence domain, it represents, so why a whole bunch of products make the same range amount of benefit together. So that's why we particularly focus on this relationship. And then definitely you might need some tool to show that so that you can see that. So how about this? So this is a tool. And just to show you, on the left side is the people's name. On the right side is locations. It shows basically all the relationship in the data. Could you find, let's see, the first one, Abdul Ramsey, the popular one, mentioned a lot of times in the document. Can you see how many people can relate in this one? It's pretty hard, right? So you need some interactions like this. So you mouse over this and basically highlight several words from this tool. Now you can see that, okay, other three people kinds of doing things with Ramsey. Sounds interesting. But then the question becomes, so these type of groups, only just the one group, or those four people belongs to several groups. So in order to find this type of things, possibly our analyst, Sarah, might move mouse pointers back and forth to see the highlights. So parts of the highlights and then figuring it out manually. So how about we change the interface this way? So now what can you see now? The same thing, the same person, Ramsey, and we show three things in the middle. So as soon as you see this, just regardless what the meaning of the thing in the middle, you could see that, okay, Ramsey seems to connect with three groups, right? So very clear, three groups. So, okay, so where these group of things comes from, right? It's not from the human. Definitely a human could find that, but maybe take much effort going back and forth, move their mouse pointer to check where the group of people are there. So here comes the machine learning. So definitely we could have different type of machine learning to find this particular type of relationship, coordinated relationship. But in this work, we focus on Bicluster. So what a Bicluster looks like. Here's a very simple example. So 3 people and 5 locations. So that means all those 3 people kinds of travel to the 5 locations to together. So it basically reveals this kind of relationship to the user. Now, think about previous view you see like this. So what machine learning can be useful for human? It definitely, first, the benefit of using machine learning is cleaning your view. Looks like this. Much better. From a complex connections with many lines, it just shows you very clear views. Or maybe you can ask like some part in the middle, highly overlap each other because of the lines try to go through one of another, but that's okay. Compared with the first one, I think most people might prefer the second one. It's less lines. So besides this, I mean, at first, the view of this layout, so machine learning can also do better things like organizing context. So what the context is, it basically the elements in the data, like the two columns. And so suppose without machine learning in this layout, how can we order the elements? So most obvious thing, we can order elements just based on the alphabetical order, like I listed here. And we can also order maybe the elements based on the frequency that maybe one people is mentioned in the documents, like this, right? So hopefully you can see that the order of the people's name a little bit different. And then we have biclusters. So based on the bicluster, we can even reorganize those things and changing the layout as I just showed before. So besides you see a clear view, another benefit of this is it potentially separates the elements in this way. Let's check that. So it seems like the first three biclusters on top kind of like just a few co-related with the things in the middle. And also on the bottom ones are not quite highly overlapped in the middle. So that means as you see this, you kind of get an overview about your data. So if I possibly explore this relationship, my focus should be in the middle part. Otherwise, I can just check the first one. Okay, I see 3 people visit 6 locations, then that's that. So just go back, check the document of what these 3 people or the 4 people are actually doing. Then you will know that. But in the middle part, you can see that the relationship goes back and forth. Much more people has been involved in some activities. That might need people or analysts to be more focused on. So then let's focus on this part. So I just kind of like zoom in that part, right? So let's start the analysis. Mouse over on the people's name, Ramsey, like what I showed before. So it seems like parts of the views has been highlighted, and maybe the user still think that there are several edges keeps going through. Let's hide it, right? So now it's much clearer, right? And because the machine learning result is displayed in context, right? The key point is we display the result in context. Then it enables us to see or maybe to gain some insights about the data. So first insights we can quickly get is, so the Ramsey kind of like do something in 3 cells, basically 3 highlighted by cluster. And it seems that Ramsey is a key person. And because of him, those 3 cells are actually connected, right? So let's see, if I had it, so you can directly see that maybe the first cell has nothing connect with the bottom 2 ones. So because Ramsey is there, so he connected 3 different cells together. So it can help the user to infer that, okay, Ramsey might be the boss or might be the key person that try to coordinate those 3 things together, right? Then, okay, let's do the analysis forward, like, okay, Ramsey 3 cells and 2 cells on the bottom, kind of like overlapped because it shares some locations on the right side. Then let's move the mouse pointer here. So suppose let's move the mouse here. So it highlights whole bunch of bicluster in the middle, just around the mouse pointers. Then let's try to mouse over another. Like, okay, so same kinds of amount of bicluster has been highlighted. So then the next question is we have this whole list of machine learning results. So where I should start, right? So mouse over something, highlight a whole bunch of that. So do you really want the user to figure out which bicluster he or she should manually check? Or we provide some ways to prioritize the machine learning result so that guide user exploration. Like, so hopefully we start triggering some additional machine learning algorithm that prioritize those related bicluster and mapping the ranking into a color. So maybe you can see that this is the darkest purple, right? And let's do it again on another bicluster. Seems like the darkest purple is still this one. So based on some feedback of additional machine learning algorithm, it kind of like review the things to the user. Like of those two similar ones, the one in the middle, kind of like both highly connected with the one that user previously seen. So let's see what this bicluster brings about to the user. Then we show the relationship, actually, we show the lines to help the user to clearly see what this bicluster really about. So now we can see that a different group of people has been reviewed, and also a different group of locations has been reviewed, right? And then it kind of gave another group of insights to the user. Like, besides the first three cells that Ramsey actually involved, so potentially there is another different group of people also kinds of doing something. And this thing might be related with Ramsey because of the people. I think the name is Faisal, just on the bottom of those three people, of those three groups. So it might say that, so those three people kind of like taking the command of Ramsey and to do something, right? Then let's get back to see the other side. So to check the locations, what those locations are. So the locations are, might be, see, you can see, try to see, LA, right? New Orleans and Atlanta. And also, much more, the more bright one is Charlottesville. So if the analyst kind of have a domain knowledge, so these locations are actually the stations on a train called Crescent. So yes, that domain knowledge is hard to gain from machine learning algorithm. So it still needs the domain knowledge from the analyst, the human, but how to enable human to think about these things. We need machine learning to inspire the human and actually display these things to the analyst. So here is actually the train looks like, and those stations should be from the bottom and just goes up, I think, to the Boston area, at least to the New York. And this is from the Wikipedia. So in summary, so if we wanted to make machine learning useful to the user, what we can think about. So first, display the result to the user. How do you display that? You need to display the result in context, rather than just give a whole bunch, a long list of bicluster, just randomly generated ID. Then the user may not get anything. We need to show the things in context. So show the things in context to allow the user to understand what machine learning gives it to them. And then we can use the machine learning to cleaning the user views to reduce visual clutter. And also, we can use machine learning to organize the context, to actually ordering things, organize steps, like move the points from the left side to right side, aggregate things to allow user actually see, okay, what's going on of their data. And also the last point is we can prioritize the information in the user's views to direct user attention to things that are potentially important. So with machine learning, we can guide a user to some part of the information and to try to trigger their attention, say, okay, this part is much more important. Start from here rather than start from somewhere else. So yes, so that is basically what I'm trying to address. Hopefully you can get some point about how you will apply machine learning and particularly interfacing machine learning to enable people to learn something. Thank you.